Hi, my name is Emma Walters, and this is a presentation on gamma radiation as a food disinfection technique, written by Sudha Adhikari, Prabha Pandey, and myself. Some key features of this technique are that depending on the dose, gamma radiation can kill or inactivate all microorganisms with DNA, such as bacteria, fungi, and viruses. This can greatly increase the shelf life of the product, as the microorganisms responsible for food spoilage are destroyed. This technique can also inhibit the sprouting of vegetables, such as potatoes, and the ripening of fruit. Radiation treatment does not change the quality or the nutritional value of the food. There can be a small thiamine reduction, but this isn't enough to cause any vitamin deficiencies. Now we move into how gamma irradiation is carried out. So the food is first brought to an irradiation facility where it's loaded onto a conveyor belt which automatically moves the product into the irradiation room. Inside the irradiation room, the food is passed under an electron beam which disinfects the product, and then the product is automatically taken back out of the irradiation room where it can be unloaded. When food is not being processed, the radiation source, which is usually cobalt-60, is stored in an underground tank of water, which absorbs the radiation energy, making it safe for workers to enter into the irradiation room. Radiation-treated food is not radioactive. This is because the food never comes into contact with the radiation source, and the dose used is quite low, so the food is not exposed to sufficient energy to cause radioactivity. Some good practice guidelines for using this technique are that all radiation facility personnel need to be qualified in radiation protection matters to ensure that the technique is performed safely. Products should be spread in a thin layer on the conveyor belt to make sure that the radiation fully penetrates the food. The irradiation facility should also be kept clean to ensure that the food isn't recontaminated after treatment. And all food that has been radiation treated is required to display the international Radura symbol to inform consumers of the disinfection technique used. Instances where this technique will fail are that viruses and endospores are more resistant to gamma radiation than bacteria and fungi are, so varying higher doses of radiation are required to kill or inactivate them. And this means that some viruses can't be destroyed without exceeding the food safety limit of 10 kilograms. Gamma radiation also doesn't destroy prions as they don't contain DNA, and these can cause several neurodegenerative diseases. The bacterium Deinococcus radiodurans is resistant to radiation, so it can survive treatment and go on to cause spoilage of the product. One example of a product that is commonly radiation treated is mincemeat. So meat is contaminated with many different microorganisms during the various phases of processing. And during the mincing process, that bacteria on the meat and also oxygen are spread throughout the product, where there is a perfect environment for them to grow. And those bacteria can greatly decrease the shelf life of the product and could also cause sickness if they are pathogenic. However, if the mincemeat is radiation treated, depending on the dosage used, it can extend the shelf life from 36 hours to 6 days without any negative effects on the product. Thank you for listening.